I want you to write this down. 2/2 of 3/4. 2/2 of 3/4. I want you to just write that down. And I know that some of you are probably already in your brain going, oh, I already know what that is. I would hope that some of you are already noticing things. Maybe not thinking, I already know what that is, because we've had a few days since we've done this. It's like when we do something and then we do something different and then we go back and review. We revisit. It kind of leaves the noggin. That happens to me. So I'm not going, oh, I can't believe I can't remember this. Things leave my brain all the time. So you think you know what this is. So Selena's like, I remember, I think I remember, I might, I don't know. And that's fine. Because I look at stuff and I go, have I done this before? It happens. Okay. So I want you to think back to that time when I had you write down on a piece of paper, back when we were doing the written expressions, the sum of this and this, the product of this and this divided by this. You remember when we did that? When we had a fraction of, what does that mean? What are you supposed to do when you have a fraction of? What are you supposed to do? No. Multiply. And that's okay if you didn't remember. I appreciate the fact that you even answered something. Because you're like, I don't know. So thank you for trying. So you are supposed to multiply. And I found that sheet. Remember how y'all said, I was telling, y'all didn't say it, I said it. I said that Ms. Ballman had made this great sheet last year that had a whole bunch of stuff on it. And I knew that I had saved a copy. Well, I found it. It was in my lesson plan binder. Right there in the book. So I can copy it and I can give it to you. It had a whole bunch of really great stuff on it. So I'm going to copy it. So this 2/2 of 3/4 is the same thing as 2/2 times 3/4. It's the same thing. It's another way to write it. And I know you're probably going, stop already. I don't like this. It's okay. There's a point. There's a point. Okay. So does anyone in the room, I want you to, you can even do it as a group. You can turn to a partner. You can do whatever you want. You just can't get up and walk around. Does anyone in the group or everyone in the group remember, I want you to turn and talk to somebody. How do you do this? Don't worry about yelling the answer at me. How do you do this? How do you get the answer? So all I'm asking, not the answer, how do you multiply these two fractions? What are you supposed to do to multiply fractions? What do you do, Daniel? That's when you add or subtract. You don't have to do that to multiply. Good try. That's when you add or subtract. You don't have to do that for this. Okay, Kobe, you gonna try again? As if you're comparing fractions. You don't do that for this. Straight across. Does this ring a bell? Okay, we did this. When you're multiplying, it, like I said, you've had a couple weeks to forget this. It's okay. I'm smiling. It's okay. When you're multiplying fractions is one of the easiest things you can do with fractions. Adding them is hard. Subtracting them is hard. Multiplying them, super easy. You just go straight across. 2 times 3. 6. 2 times 4. 8. That's it. So 2 halves times 3/4 is equal to 6/8. That's it. Now I know that if you did the cross multiply thing, you would still get it, but you do not cross multiply when you multiply. You don't. Because you're not always going to have the same numerator and denominator. I might multiply 2/3 of 3/4, and then I'm really going to have a messed up answer. So you hear me saying, do not cross multiply. Do not cross multiply. Okay. So what I'm going to do you notice? Oh, so what I'm going to do, and some of y'all might go, I don't like this. I'm going to just show you. You do not have to do this. I'm going to show you the visual, the picture of what's going on. So first I'm going to show you 3/4. 3/4. So if I have a bar, and I would split it up into 4ths. 4. I would color in 3. So that's 3/4, right? So when I'm taking 2 halves of it, I need to split this into halves. So that's showing that 3/4 in halves is equal to 1, 2, 3, 4, 5, 6 out of 1, 2, 3, 4, 5, 6, 7, 8. 6 out of 8. It's just an area model showing the fraction. Do you have to do this?
No.
No, it's just a visual. Yes, ma'am.
Will it work with any other number?
How does the size of the product, right here, the product is what you get when you multiply. How does the size of the product compare to the size of this, of 3/4, to the original fraction? How do these compare to each other? How does 6/8 compare to 3/4? You guys need to talk in your group. I'm going to give you 15 seconds. So in your group, I want you to talk about how does 6/8 compare to 3/4? Okay, let's see. I'm going to pick this middle group right here. No, wait, I need to call back here. Okay, this group back here. How does 6/8 compare to 3/4? They are equal. Why? Why? Well, you're not going to cross multiply. Not cross multiplying. But they are equal. I would use the word equivalent because, Laura,
You multiply 3/4 times 2, you'll get, and if you divide 2 by 6/8, you'll get 3/4.
because if you took the 3/4 and you multiplied it by 2 halves, you multiplied the top and the bottom by the same exact number. You're going to get 6/8. If you took 6/8 and you simplified it or divided it by 2, you're going to get 3/4. Even showed it using the area model where I had 3/4, and all we did was draw a line down the middle. Did the green shaded section change? No. All it did was have a line in the middle of it. It's still the same amount, technically, the same amount of green shaded spots. Okay. So, now we're going to, good job, guys. Now we're going to take a fraction and we're going to turn it into a decimal. Now, first thing, before we can do that, I want you, who in this room, I want you to think about it real hard before we even move further. Now, this is a first quarter thing. I want to see if anyone can remember this from first quarter. Now, I took the anchor chart down, so you can't even look around the room. It's gone. I put it up. Who can remember what the powers of 10 are? Ooh, I might have to pull a stick. I got a lot of hands up. The powers of 10. So, let's see. I'm going to pull a stick because I don't want to be like I'm asking favorites. Okay. Well, I don't like any of y'all. Just kidding. Just kidding. Okay. All right, let's see. And I'm not even looking at the sticks. Caitlin.
Knew it. Oh.
Darn it. Okay. What are they?
It's 10, 100, 1,000, and so on.
Right. 10. It's multiples of 10. So the powers of 10 are what you need to make a decimal. So the powers of 10. So you need like 10, 100, 1,000, and so on to make a decimal. This is what you're going to need to make a decimal. You need powers of 10 to make a decimal. If it goes up on the smart board, where does it go?
On the paper.
On the paper. She needs to finish her social studies test.
Bring it with you.
So, are needed to make a decimal. And sometimes making a decimal is easier one time than another. Now I'm going to show you more than one way to do it. I don't really want to call it a cheat, but it's another strategy. Because isn't there more than one way to get to Birmingham?
Yes.
Yes. There's more than one way to get to Gulf Shores. Mm-hmm. Yes. So if I'm going to take a fraction and turn it into a decimal, the first thing I need to do is I need to have a fraction, which I haven't written up here yet because someone stopped. Okay. So I'm going to start easy, I would think. 1/4. Now, before you start going, how do you do that? I saw Alora's face doing the, what? She had the thinking. If I could have seen a little thinking cloud pop up, it would have been like, and with the, how do you do that? I don't get it. I don't understand. What on earth is she doing? Why did she write 1/4 up there? That would have all been in that little thinking cloud right there, right? I haven't even done anything yet. So we're going to learn how to go from here to a decimal. I'm going to show you 2 different ways. And when I show you, you're probably going to go, oh, that's not hard at all. Okay, so I want you to look at, now you have to know your powers of 10. If you don't know 10, 100, 1,000, you need to go back to first quarter. Okay, but you have to be paying attention and not playing with your pencil or a pen insert, which needs to be going away. I got a perfect place for it. I call it file 13. It's that trash can over there. Okay, so we're going to have to get 4 to a power of 10. So we're going to have to multiply this fraction by something. So 4 times something. So I need to think about, it's almost like finding a common denominator. So I'm looking at my powers of 10. Can 4 go to 10? Now we're doing evens. Can 4 evenly get to 10? No. So my denominator over here can't be 10. Can 4 evenly get to 100? Yes. You think about $1. Ah, 4 of what? 25. 4 quarters makes $1. So my end product needs to be 100. So 4 times what gives me 100? 25. So I have to multiply the entire thing because I'm making an equivalent fraction. Oh, there's a thought bubble with in there, right? So I'm making an equivalent fraction. What you do to the bottom, you do to the top. So what is my equivalent fraction that's equal to 1/4 that I can now turn into a decimal? What goes up here? 25, because 1 times 25 is 25. How do I say this? 25 hundredths. 25 hundredths. So and fractions are the same thing as division and decimals, but division. When you, oh, this is something else from first quarter. When you divide by a power of 10, I'm going to pull those anchor charts back out. John Cena, you can't see me. Where is that decimal? Where is it? It's what?
Behind the number.
It's what?
Behind the number.
Behind what number? I got so many numbers up here. Which one? What last one? Where are you at? Behind what number? Behind the 5. It's right here. You can't see me until you need me. Well, I need it now. So how many spots am I going to move it? It's 25 divided by 100. How many spots are you going to move it?
2.
2. Which way?
To the left.
To the left. So it's almost like you got to keep it shuffled. That way. So 1, 2. 25 hundredths. The decimal representation is the same as the fraction. The way you say it is the way you write it. 25 hundredths. The 5 is in the hundredths place. 25 hundredths, 25 hundredths. Oh. Have you been writing this stuff down? Because I'm not going to wait. All of this? All of it? If it's up here, you write it all. The numbers too, because I know you've been watching, but you haven't been writing. This is the other way to do it. So, yeah?
If it can't go to 100 evenly, do you move to 1,000?
Yes. Now, so, I don't know if you heard Selena. She says if it can't go into 100 evenly, do you go to 1,000? Yes. If it can't go into 1,000 evenly, you go to 10,000. You go to the powers of 10 that it can go into evenly. And that's when sometimes the numbers get really hard and you do it the way I'm about to show you right now. Kira, I don't think I'm that boring. Okay, so, yeah, it will eventually. But, so hold on, no, sometimes it won't, and that's why you do what I'm about to show you. Okay? All right. So, 1/4. Aren't fractions a representation or a way to show this? Division. Thank you. So, 4 divided into 1. How many times can 4 go into 1?
None.
None.
How many times can 4 go into 1? None. 0. 0 times. So that would be 0. I'll bring that down. Since I'm making decimals, what am I supposed to do now? What? I know I did not hear the word point. Decimal. 0. Bring that baby down. Now I divide into 10. Now this only works if y'all actually know how to divide. Some of y'all never did master division. 4 goes into 10 2 times. 2 times 4. 8. Oh no, I still have a remainder. Can I have a remainder when I'm doing decimals?
No.
No. Keep going till it's gone. Add another 0. Bring it down. 4 goes into 20. 5. Still get the same answer. So you either do, now there are some that maybe on the test or the homework it will ask you to do it like a fraction. So you still might want to try it. But this is why sometimes when you do it on the calculator, which I still want to see you do it, try it like a fraction. Right now it's going to be really easy. I want to see you try it like a fraction. Some of them might be a little bit more difficult. Yes?
And you could try it in the box too. By how to divide.
Mm-hmm.
And you can do it in the box.
Mm-hmm. I tried, was it that box method? I've tried it. I get it with regular division, but I just don't know how it works with, or whatever that one that Miss Nelson came in and showed. I just don't know how it works when you've got a decimal. I just don't get how you're supposed to figure out with a decimal system. Huh?
What about the cabbage method? I don't know. Once you were like, some teachers taught you the cabbage method.
I don't know what I'm talking about. There's no telling. Sometimes I say stuff I don't even know what I'm saying. Okay. So let's try. Where's my sheet? Oh, it's way down here. No. Scroll up. There we are. Okay. So you have, I'm going to give you your problems. What whole fraction should go right here to make 21 28? Just tell me.
7
7 sevenths, because 3 times what gives you 21? 7. And what you do to the bottom, you do to the top. What you do to the top, you do to the bottom for a whole fraction, because we need to get something that would be equal to 1. So we needed 7 sevenths. We needed it where the numerator and the denominator were the same. So here, for 7/4 to be multiplied by some whole fraction to make 35 20ths. So what would I multiply here? What whole fraction would go in there? 5/5. So when they're asking, using words to compare the size of the product to the size of the first factors, how do they compare? I told you put it up. So how do they compare? Alora, They are equivalent. Because, why are they equivalent? Because why?
Because you're multiplying with factors by the number.
That is equal to, you can't say you're multiplying it by a fraction that's equal to itself. That's not really it. You're multiplying it by a fraction that is equal to a whole by that's equal to 1. So because you are multiplying make sure I'm wording this right, by a fraction equal to 1. So because every single one of these fractions was equal to 1. Your fraction, your product, this product right here is equivalent or equal to the first factor, my initial number right here. It's equivalent, it's the same, it's just bigger because I multiplied it by a fraction that's equal to 1. I just made it bigger. It was just equal, just bigger. So I multiplied it by a fraction that was equal to 1. All right. So this bottom part. So we had 1/4 times 25 25ths. The top part, they had already done it for you. So you should have had 1 times 25 was 25. 4 times 25, 100. So you were trying to get to a power of 10. You don't leave it just like a fraction. You were supposed to make it a decimal. So using Mr. Dull, I have my numerator, 25. I use different colors here. Decimal 25 goes in 2 times. 1, 2. So 25 hundredths is what your decimal should look like. Your answer, your final answer should look like that. That's what you should have. And if you don't, you need to be writing it down because you will have homework this evening. And if you get home and you go, I don't remember how to do this, what should you do? And
Watch the video.
watch the video. I'm recording it, as always. Okay, 3/4 times 25 25ths. 75. 4 times 25 is 100. I have my 75. Make my decimal visible. Goes in twice. 1, 2. 75 hundredths. What your final answer should look like. You guys should be just doing a whole bunch of this, and maybe that's not exactly what I got to put my decimal in the wrong place. I'm happy to see these because really they gave you the numbers. Okay, so down here, this is where maybe there was a little bit more work involved because you had to really think about your powers of 10 and how do you get there. So thinking about your powers of 10, 10, 100, and I remember having to do this last year for some people, having to write the powers of 10 off to the side because some people, they were writing their numbers in the wrong place and it was messing them up. So 5, and I always start small. I hate going to the big numbers. 5, can 5 go to 10?
Yes.
No.
Yeah.
Yes. So that's my end product. I'm not going to write it here because then I end up with a denominator of 50. Is 50 a power of 10?
No.
No, it's a multiple of 10. 10, 20, 30, 40, 50. It's a multiple, but it's not a power of 10. 5 times what gives me 10? 2. So I've got to multiply by 2 halves. 1 times 2, 2. So I've got 2 tenths. Is what you should have. So So I've got my number 2. Make my decimal visible. Only going in one spot. 1 0 to the left, 1. 2/10 right there is what you should have. If you do not have this stuff written down, write it down right now. That's now the second time I've said it. You should have a pencil in your hand and writing it down if it is not on your paper. 4/5. Well, I already know over here that 5 is going to 10. So my power of 10 is 10. 5 to get to 10 is 2. 4 times 2 was 8. So we had 8/10. There's my decimal. How many places was my decimal moving in? 1. Right there. 8/10. So was this as difficult as you thought it was going to be? No, not at all. 1/20. So I've got to multiply it by something and try to get to something. So here they gave you blanks and stuff. Here they gave you nothing. So I just write what I needed because I need this to make sure I don't forget what I'm doing. Because you know me, and I forget everything. So what power of 10? Can 20 go to 10? No, 10 is smaller. I'm not going to 10. Can 20 go to 100?
Yes.
Yeah. So, and if I don't automatically know, then I might take that 0 off and think of it as a 2. So if I take a 0 off here, I can take a 0 off there. 2 to 10. Can do that? Can that happen?
Yes.
Yeah. So then 20 can go to 100. How many times does 20 need to go to 100? 20 times what? 5. So 1 times 5?
5.
5. So I've got 500. Now I did see an error on this because people are doing decimals in their heads and not really doing it on the paper. And if your decimal is in the wrong place, is your answer right?
No.
No. How many places is your decimal moving?
2.
2. 2 places. And if you only go like this, it's wrong. That's 5/10. It's supposed to move 2 places right there. So what are you supposed to do?
Add a 0.
Add a 0 because that's 5/100. So if you only have one decimal place and you've got decimal 5, your answer is incorrect. Your decimal is supposed to move 2 spots. Deshaun. Not what you're supposed to be doing. You're supposed to be doing this. That can wait till later. And again, 20, we're going to 100. 20 times 5 got us there. So 27 times 5, I don't know that off the top of my head. I know it's going to be pretty big, so I'm going to do that off to the side. That's 35. That's 13. So I've got 135. And you go, oh my gosh, that's an improper fraction. Do you need to bother making it an improper fraction?
No.
No. I'm just going to write my number, move my decimal in. And it'll go in 2 times. I start here and I go 1, 2. Now, you're not wrong if you make it an improper fraction. You're just adding more work if you do an improper fraction or a mixed fraction. Because what happens if you make it a mixed is like you'll do 1 35/100. This is where you are if you make it a mixed fraction. Don't do this. This is what I'm saying. This is where you are if you do this. Okay? Because I know a lot of y'all, you're trained from second quarter to go, improper, must make it fixed. When you're doing a decimal, don't do this. If you accidentally do this, if I say 1 34/100, what does and mean? Decimal. So this means it's the number in front of the decimal. 1 and 35 hundredths. So this just means this is behind the decimal, this is in front of the decimal. It's not the end of the world. This just means that I've got 5 in the hundredths place, 3 decimal 1. It's not the end of the world if you accidentally make it a mixed fraction. It's just you have to really think about it more. It's easier if you leave it improper, okay, and just move the decimal. I wouldn't do this. Okay, 7/4. So I'm just gonna look it up. Oh yeah, look, went to 100 because 4 can't go to 10. It went to 100. If I've already worked something and I already figured it out, am I going to work it again?
No.
Or am I going to look where I already worked it? I'm going to look where I already worked it. But they have a saying, it's called why reinvent the wheel? It's already been invented. Why invent it again? If I've already worked it and I already know that 4 can go to 100 25 times, why figure it out again? It's already been done. So we know that 4 times 25 is 100. I mean, if I think about, if I use what I know about quarters, how much money do I have if I have 7 quarters? No! Okay, how much is 4 quarters? How much is 4 quarters, Laura? $1. And then I have 3 more quarters. So this is $1.75. So 7 times 25 is 175. So I just did math without having to write it down. Only because I thought about it as money. But I could work it out. I just didn't do it. So 175 to the decimal. How many spots do you move it in?
2.
2. 1, 2. So it's 1 and 75 hundredths. This is so much easier than I thought. And it's kind of intimidating when I told you we're going, I'm going to teach how to make fractions of the decimals. And y'all were like, Alora's thought bubble. What? No. Yeah. Is it that bad? No. No, it's really not. And I mean, even if I showed you dividing 4 into 7, like a division problem, you would still get this. You would get it. 4 into 7. How many times can 4 go into 7? Once. That, because no remainders. Decimal. 0. But you have to know how to divide. 28. You get the same answer. Well, I just didn't write down 20. I was running out of room. Yeah, but you still, for, I prefer division myself. And whenever you plug it in a calculator, that's the way the calculator does it. They just divide it. Like the calculator just does like an algorithm and does like the division. I don't think a calculator sits there and does the fraction. But this, like I tell you that the math that we do now, that a lot of times, and people my age, technically, even though I'm older than a lot of your parents, your grandparents, they hate this because it's hard to understand. But you guys are lucky because you're learning another way to do it. You may not like this, but it's cool that you are fortunate enough to learn this way and this way. You get a choice. We weren't fortunate enough to learn options. We didn't get choices. It was, this is it, that's the only way. So, whereas you get this, and this isn't really that bad. It's really not that bad. Because sometimes this is easier than division. Sometimes the division is easier. Sometimes this is easier. I showed this to, it was either Reagan or Emily, because she was doing this at one point, and I showed it to her. She was like, man, I wish I knew how to do that. I wish they had taught me that. Because sometimes this is easier than division. Are you having trouble holding on to that eraser? Pick it up, put it on the pencil. Sometimes this is easier, sometimes division's easier. It depends on which one you're doing, what number you have. So 8/5, I already know that 5 is going to 10. So I know that I have to multiply by 2, and I have 16/10. When I have 16, I'm moving my decimal in once, 1 and 6/10. And since we all, since we know our powers of 10, this really is kind of faster than doing division, especially for the people who struggle with division. Okay, so the 25, what power of 10 am I going to?
100.
100. So I have to multiply by 4. What numerator did you end up with?
96.
96. So my decimal would move in 2 times, 1, 2, and you would have 96 hundredths. What power of 10 for 50?
100.
100. What do you have to multiply by?
2.
2. What numerator?
186.
186, because 2 times 3 is 6, 2 times 9 is 18. 186. Bring the decimal in 1, 2. 1 and 86 hundredths. Okay. Now the ones that came to you already mixed. Oh my gosh. 2 and 6/25. So all you have to do is kind of ignore the 2 for a second, because it's in front of the decimal. All I'm doing is changing the 6/25 into a power of 10. I'm making an equivalent fraction behind the decimal into a power of 10. So I'm going to kind of bring out my 2 and kind of pretend it's not there, because I need to turn the 6/25 into something else with a power of 10. So it's going to be 25 is going to become 100. 25 times 4. So then we have 24. So it's going to be
24.
So it's 24, 1, 2, 2, and 24 hundredths. Because I've got the 2 wholes that was part of my mixed fraction in front of the decimal that was already there. My 2 that I already had. 2 and 24 hundredths. All I was doing was turning this into a decimal. So then I bet you guys could do that one. And if you did, then you should get 3 and 62 hundredths. You're like, this is so easy now. Okay. Jake said that if you take a number and multiply it by a fraction, the product will always be smaller than what you started with. Is he correct? Why or why not? So if you take a number and multiply it by a fraction, the product will always be smaller than what you started with. Is he correct?
No.
Why? Give me.
Because like on in the front of the page, we multiplied it by a whole number, and sometimes it was bigger than the whole number.
So if I took, so no, he's wrong. And so if you say I took, I'm going to take a fraction that's like the 3/4 that we used earlier. If we took it, what happened when we multiplied it by 2 halves? 2 over 2.
It became 6/8.
It became 6/8. How did 6/8 compare to 3/4? Was 6/8 bigger than 3/4? Was it smaller than 3/4?
Equal.
It was equal because he said the product will always be smaller. Is this smaller? Is 6/8 smaller?
No.
No. This 3/4 was equivalent to 6/8 because all we did was we multiplied it by a fraction that was equal to 1. Okay? So now if I took 3/4 and I multiplied it by, say, a half, I get 3/8. And I compare 3/4 to 3/8. So this one will be 24, this one's 12. Which one's bigger, 3/4 or 3/8? I think I did that back. I think I did that one backwards. I don't cross multiply very often. So there's the fourths, and then this one is the eighths. This is 3/8. This is 3/4. Which one's bigger? 3/4. So did 3/4 get bigger or smaller when you multiplied it by this fraction? It got smaller. So that one he proved his point because 1/2 is smaller than 1. If it's smaller than 1, your fraction will get smaller. So what if I took 3/4 and I multiplied it by 5/4? So do you think 3/4 got bigger? Do you think my fraction got bigger or got smaller?
Bigger.
It got bigger. And the reason why is because this is more than 1. If the number, and we're going to do this more tomorrow. This is our lesson for tomorrow, actually. If the number that we're using to multiply, what they call the first fraction, okay, if the number that we're multiplying with I think they call it the scaling. If it's less than 1, our product is smaller. If it's 1, it's equivalent. If it's bigger than 1, it's bigger. That's all you gotta do is compare it. How does it compare to 1? Is it less than 1? Well, then it's smaller. If it's bigger than 1, it's bigger. If it's equal to 1, it's equal. That's all you have to remember to that. You just have to compare the scaling to 1. So he is incorrect because he used the word always. It's not always true. We disproved that one right there with what we were doing today. There is an infinite, you know what infinite means?
There's no
ending.
There's no end. It goes on forever and ever and ever. There's an infinite number of ways to represent 1 on a number line. In the space below, write at least 4 expressions multiplying by 1. So my example, my expression multiplying by 1. Represent 1 differently in each expression. So this is equal to 1. This is because when my numerator and my denominator are the same, did you learn this when you were learning fractions? When your denominator and your numerator are the same, it's equal to 1. Because all my pieces are there.